Your toilet has no motor, no pump, no electricity. Nothing plugs in, nothing spins. And yet it can empty an entire bowl of water in about 4 seconds, faster than that bowl could ever just drain on its own. So what's actually pulling the water down? It isn't falling. It's being yanked up and over a hidden hump by a trick built into the porcelain that you've flushed 10,000 times and never seen. Once you see it, you can't unsee it. Look at a standard toilet and you see a bowl and a tank. What you don't see is the most important part, and it's built right into the ceramic. Behind the bowl, there's a tube that curves up, arcs over a hump, and then bends back down toward the drain. From the side, it looks like the letter S lying on its back. Plumbers call it the trap, or the trapway. That shape is the whole secret. To leave the bowl, water has to first climb up and over that internal hump before it can fall to the sewer. And here's the clever part. Because the water has to go up before it goes down, some water always stays behind, sitting in the low part of the bend. That standing water is the pool you see in the bottom of the bowl. It isn't leftover. It's there on purpose, and every single flush destroys it and rebuilds it in seconds. Watch. When you push the handle, you are not pushing anything down the drain. You're just dumping water into the bowl, fast. Here's the sequence. The handle lifts a rubber stopper at the bottom of the tank called the flapper. That opens a big hole, and the tank empties into the bowl in just a few seconds. Most of that water rinses down through holes around the rim, but some of it is aimed through a jet at the base of the bowl, fired straight into the trap. That jet is what actually kickstarts the whole thing. This matters. It's not a trickle, it's a dump. A large volume of water arrives all at once. That flood raises the water level in the bowl faster than the trap can drain it normally. The water climbs the bowl, rises up the inside of that S-tube, and reaches the top of the hump. It spills over the crest and starts pouring down the far side toward the drain. And that is the moment the magic starts. Once water is running down the far side of that bend, the tube fills completely, with no air gap. Now you've got a full tube of water arcing up and over the hump and down to the drain. Gravity pulls down on the long downhill side, and because the water is one connected column, that falling water drags the water behind it along too. It pulls water up the short side and over the top. That's a siphon. A filled tube plus gravity will lift water uphill as long as the outlet sits below the water level back in the bowl. And to be clear, no pump is sucking here. It's the weight of the falling water plus normal air pressure pushing down on the bowl, doing all the work. The whole bowl gets pulled up and over the hump and down the drain. This is where the loud, fast whoosh comes from. The bowl empties in seconds, way faster than it could ever just drain. But a siphon has a built-in self-destruct, and you can hear it. A siphon only works while the tube stays full of water, so the flush is a race. It runs great right up until the bowl runs low and starts pulling in air instead of water. The moment air gets into that tube, the water column breaks. The connected chain snaps, the pulling stops instantly, and the siphon dies. That's the gurgle. That specific glug-glug at the end of a flush is the sound of air breaking the siphon. The show's over. Now the bowl is nearly empty. But remember that pool of standing water that was there when we started? That was doing a job, and now it's gone. So before we go anywhere, the toilet has to rebuild it. That pool of water in the trap is doing a job every second of the day. It's a seal. Below your toilet is a pipe that connects to the sewer. And the sewer is full of gas. Hydrogen sulfide, the rotten egg smell, plus methane, which is odorless but flammable. That gas wants to rise up the pipe and into your house. The pool of water in the trap blocks it. Gas can't push through standing water, so it stays down where it belongs. This is why every drain in your home has a trap of some kind. The toilet just has its trap built into the porcelain instead of hanging under it. The water is the door, and it stays shut as long as the water is there. Which is why the toilet's very last move on every flush is to quietly put that water back. Lift the tank lid, and it looks like a mess of plastic, but it's only 2 jobs. Let water out, then put water back. The flapper is job 1. It's the rubber seal that lifts when you flush and drops back down to plug the hole once the tank empties. When it seals, the tank can start filling again. Job 2 is the fill valve and the float. As the tank empties, the float drops, and dropping opens the fill valve to let fresh water in. As the tank refills, the float rises, and when it reaches the top, it shuts the valve off. Float drops, valve opens. Float rises, valve shuts. No sensor, no electronics, just a float turning water off like a lever. One more detail people miss. While the tank refills, a small tube also squirts water down into the bowl on purpose. That's what rebuilds the water seal in the trap, so the sewer gas stays blocked and you're ready for the next flush. So simple it seems foolproof. It isn't. Here's everything that goes wrong. The leaky flapper. If the flapper doesn't seat perfectly, water sneaks from the tank into the bowl. The float slowly drops. The fill valve kicks on to top it off, and you get a toilet that hisses or seems to flush itself at 3 in the morning. Those phantom flushes can quietly waste a surprising amount of water, and a worn flapper is the usual culprit. If you've lived with a toilet, you've probably heard this one. Clogs. Because everything has to climb up and over that trap, the trap is the choke point. Anything too big or too much at once jams in the bend, the siphon can't form, and the bowl won't clear. A plunger works by shoving water back and forth to force the blockage through the hump. No suction, just push. That's all it's doing. Water use. That fast dump of water is not free. Older toilets used a lot, roughly 3.5 gallons or more per flush. Modern ones are built to do the same job on far less, commonly around 1.6 gallons, and high-efficiency models near 1.28. The engineering challenge is starting a reliable siphon with less water, which is exactly why that jet and the bowl shape are designed so carefully. And one more, the dry trap. If a toilet goes unused for a long time, that seal water slowly evaporates, and the sewer smell drifts into the room. The fix is almost funny. Just flush it and the seal is back. So let's kill the 2 big myths. Myth 1, a toilet is just a drain. It isn't. A drain lets water fall straight down. A toilet forces water up and over a hump so it can trap a seal and trigger a siphon. That extra bend is the entire invention. Myth 2, it needs power or a pump to move everything. It doesn't. There's no motor, no impeller, nothing electric in a standard toilet. It's a tank of stored water, a rubber flap, a float, and a very cleverly bent tube. Gravity does the work. You just pull the trigger. That's the whole thing. A bucket of water, dumped at the right speed, into a tube bent at the right angle so that gravity briefly turns your bowl into a siphon and then politely refills itself for next time. Subscribe to Whambox for more How Does It Actually Work explainers.